Okay, when we go and add and subtract radicals, that's the same as when we work with our exponents. For example, when we have x squared plus 3x minus 2, can we put any of these together? No, you can't, because they're all separate, right? The x squared stays separate, the x's, and then the little units. Well, and then if we had like 2x squared plus 4x, you don't need to write this right now. Hold on. Minus 7 minus 6x plus 3x squared. What can you put together here? All right. The 2 and the 3x squared, which is 5x squared. We kept the x squareds the same. Then you have 4x and minus 6x. Negative 2x or minus 2x. The negative 7 doesn't have a buddy, so it stays like this, right? The radicals are going to be the same. The square roots are going to be the same thing. Now, this is not the front. This is what I'm trying to tell you guys. It's not the front of your paper. Stay on the back and write these down as notes. This is just, they look kind of the same, but they're not. This says square root of 7 and square root of 7. That means that they can go together. This is saying I have 4 square roots of 7 and 5 square roots of 7. 4 plus 5 is 9, and square root of 7 stays the same. Just like if I was doing 4x plus 5x, this would equal 9x. Okay, the x's are just telling me what goes together. That's what those square root of 7s are doing. You can't do anything with the 7. You just leave it like that when you're adding and subtracting only. Now, the next one right here, we are subtracting. What you're going to look at first is the fact that the square roots are the same. So that means that they can go together. So now, and the question was, what if they're different? We're not there yet. So now we have 8 minus 2, which gives you 6 square root of 11. Okay. Next, right here. Now you're going to see that these are all different. Well, except 2 of them can go together. I see that I have a square root of 6 and a square root of 6. I can't take 6 down any farther. I mean, it's 2 times 3, but nothing can come out. So 6 is the lowest this square root sign can go. Same with 13. 13 is prime. So the only things that can go together are the 3x, or I'm sorry, not even x, 3 square root of 6 and 5 square root of 6. What is 3 plus 5? 8 square root of 6. This one doesn't go with anything, so you just write minus 2 square root of 13. So because these are not the same right here, okay, you can't put them together. Yes, so the question was, if say this was the square root of 2, right here, say this was 5 square root of 2 instead of the 6, that would be the simplest it could be. Okay? Here's the next one. Let's write this one down and try this one. In this problem, you're going to look and see which ones go together. I have the square root of 3, and here's the square root of 3. What number's here in front of the square root of 3? It's a 1. If there's not a number, it's a 1, remember? So I'm going to have 7 minus 1, 6 square root of 3. Then I have square root of 2. 2 minus 3 is negative 1, so I have minus 1 square root of 2. You can write minus 1 or just use it as minus square root of 2. That's as simple as it goes. That's as low as it goes. You can do this. They mean the same thing. Okay? There's number 5. Now, in first sight, looking at this, the 3 doesn't go with the 192. But we need to break 192 down. I know a 2 goes into both of them. Because, see, I don't know off the top of my head what divides into 192. I know that an even number, 2 goes into it. So I'm going to start that way. So 192 divided by 2 is 96. Thank you. Looking at this, I can I'll just use a 2 again for fun. Because I know it's even. 96 divided by 2, 48. Break this down again. Well, 4 goes into it. Oh, 12. Sorry, 12. You can do 2 and 24 if you want to keep doing it that way. It doesn't matter. There's different ways you can do it. And then 4 splits up into 2 and 2. All right, these are still prime. So now my 12, 2 and 6, or 3 and 4, whatever. 6 is 2 and 3. All right, there's a whole lot of numbers going on right here. Okay, so let me put them all underneath the square root sign so I can see it. 1, 2, there's 2 2's. Here's 2 more. 2 more. And then the 3. Whew. And don't forget about the 5 that goes out front. Okay. Now, the only way you get to go outside is if you have a swimming buddy, a partner in crime, whatever. All right, so I've got the 10 and I've got a 2 comes out. Another 2 comes out because there's another pair. There's another pair. Who's left in the house to do all the cleaning? 3. Now, you need to multiply these numbers together. 5 times 2 is 10. 10 times 2, 20. 20 times 2, 40. Okay, so this becomes 40 square root of 3. Oh, it is. All right, so this is actually 40 square root of 3. Now, if you could find, let's see, what did we have? 2, 4, 6, right? 2, 4, 6. So I think 36 times 3 is 190. No? 2, 4. Two, 4, 6. I don't know. If you can find the perfect squares in there, more power to you. That's what I'm saying. This is the easiest way for me to make sure I don't make mistakes. Now I go 40 minus 7, which is 32 square root of 3. Okay. Number 5. That's not number 5. That was number 5. Number 6. Time out. Hold on. I just got called out because I listened to my friend in the back. Well, 40 minus 7 should be 33 square root of 3. I was trying to answer Ariel's question and listen to Edar. Big mistake. Okay? All right, so it's 33 square root of 3 because 40 minus 7. Okay? Now, this one that I told you guys to start on, the square root of 2 is as simple as it goes. We've got to simplify 27. Now, if you see this is probably better than writing it all out. I've got 9 and 3. Okay? Well, first off, I know 25 square root of 2 will stay the same. What's the square root of 9? So you can go 2 times 3 square root of 3. Because you bring square root of 9. Yeah. Because that would be the same as having the 2 out there and taking 9 splits up and go 3 and 3 and 3, right? Okay. Let me go back. I'll just, instead of doing the shortcut. Here we go. All right, 27 is 9 and 3. 9 is 3 and 3. So underneath the square root sign, I get 3 times 3 times 3. But this 2 is out in front still, right? Because it's up there in the beginning. Now, how do you get to come out of the house? You have to have a buddy, okay? So these come out right here. So I have 3, and then I write what's left, times 2, square root of 3. 3 times 2 is 6, plus 6, square root of 3. Now we need to do 98. 4 and 7 to get 98. Oh, did you write 28? Okay, 98. I'm just going to start with a 2 because it's even. So what is that? 49? 98 divided by 2. Okay, it's 49. 7 and 7. So now I get, remember there's a minus 3 out front, and I have 2 times 7 times 7. I got a pair. So the 7's come out, times negative 3, square root of 2. 7 times negative 3, negative 21, square root of 2. Okay, what goes together? The square root of 2. We're comparing simplifying radicals to eating crawfish. You have to break it apart, and it's a lot of work to get to the little bitty answer. I would agree with you. Okay. 25 minus 21 is 4 square root of 2. And then, right, you can't put together your square root of 3, right? It's like when you go to eat and your food can't touch. You have to keep them separate. Y'all know, oh, please, y'all know people do that. Not me, my children do. How many of these? Oh, this is the last one. Woohoo, winner, winner, chicken dinner. Do this one right here. Let's go. Square root of 3 is as simple as it gets. Square root of 6 splits up into 2 and 3. I can't do anything with it. So 7 square root of 3 minus 4 square root of 6. I'm going to leave those alone. But I have to look at 48. 48, 4 and 12 works. 4 splits up as 2 and 2. You can do 2 and 24. It doesn't matter. It's as long as the prime ones down at the end are all the same. 2 and 6. 2 and 3. So underneath my square root, so I've got a 2 out front. I've got 2 and 2. And the 2 out front, guys, came from that right there. Then 2 and 2. And then a 3. These 2's can go outside, and these 2's can go outside. So I have 2 sets. There was already a 2 sitting out there. Wait. Your question. Let me finish this, and then I can answer your question because I'm trying. 2 times 2 is 4. 4 times 2 is 8. So this becomes 8 square root of 3. Now we have to break apart the 54. 9 and 6 will work. And 9 breaks up as 3 and 3. 6 is 2 and 3. Square root. 3 times 3 times 2 times 3. But wasn't there a number out in front? Yeah, so let me put the negative 6 out here. All right. I put it down in the prime numbers. I have 3's that go out front. So I have 3 times negative 6 square root of 2 times 3 is 6. So this is negative 18 square root of 6 minus 18 square root of 6. Okay, now let's put together the ones like square root of 3. Square root of 3. 7 plus 8 is 15. Square root of 3. Negative 4 square root of 6 minus 18 square root of 6. Negative 18 and negative 4, negative 22 square root of 6.